This podcast is presented by HANNOVER MESSE, your leading event for industrial AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Sieber. Good morning, Robert. Welcome to you, dear listener.
Thank you, Peter. It's the last week of work for me.
For you?
Yes, because as I will strapping my skis on the car on Friday evening.
Skis in the end of March.
Yeah, absolutely.
The Alps.
Yeah, of course, I'm already checking our AI in the Alps locations. Yes.
Ah, very good.
Yeah.
I'm looking forward to the sun. You're looking forward to the snow and the sun, I guess.
I'm looking for the snow, the sun, and the good food at the Rote Wand.
Ooh, wonderful.
Yeah. But there's still a lot of podcast recordings in my diary this week. AWS, Backhoff, software-defined automation, ASML, etc. So I still have a lot to do.
Busy.
What do you have in the news section?
Two pieces. I think we're talking a little bit about regulation both today, right? So first is the AI Act. Of course, since last Wednesday, I believe that is the European Parliament. They approved the AI Act. We've been talking about it from the beginning, 5 years, I guess. I believe really in the first months that we started was that January of 2019. I think I was already at that time in Brussels.
Yeah, you were in Brussels. Yeah, I remember.
Yeah, I was not one of the designated, whatever they were called, 170 designated, elected people. But nevertheless, I was there and I gave my bit of whatever it was. So there we go. 523 votes in favor, 46 against, 49 abstentions. Now, I'm not going to, and I'm going to keep it very short anyway. And this is not, I'm not a consultant on the details of the AI Act. Just 1, 2, 3, 4 points. So number one, we're going to have banned applications, right? So that is social scoring is going to be banned, CCTV footage, a couple of other things. We know that. There's going to be exemptions in case of, looking for a missing child or preventing a terrorist attack. That's the first category. Then there's going to be the category of high risk systems. I'll talk about industrial. Yeah, I'll do that later, but it's including critical infrastructure, education, employment, healthcare. So things that are very close to us humans, to us European humans, so to say, right? And those systems need to reduce risk. They need to be transparent, a couple of other things. Then there's a separate category, what they call general purpose AI, GPAI. I believe that's what we humans call LLMs these days. Yeah. Right. I believe so. They need to comply, of course, European copyright. And it says the more powerful GPAI models. And that's where I made an exclamation mark. That's, of course, everything to do with the politics of the smaller system, the smaller open-based European systems you recall. I'm not going to go into that for the moment. And then one more point, which is most also, I believe, important, is that any deepfakes, what they call artificial or manipulated images, audio, they need to be clearly labeled. And final point, maybe next steps, they're still subject to final lawyer linguistic check, and it's going to be adopted. And then there's many different, I think 24 months after it's going to be published in this official journal, it's going to be kind of live, but then already for whatever is prohibited is already, after 6 months. And I think the GPI is already after. So it's all not that very clear. I downloaded the PDF. It's 439 pages on my screen. I think it's always a little bit different, but there you go. And what I did is in the PDF, I looked for industrial. Industrial AI, of course, that's what you, dear listener, are interested in. And industry, there were only 5 spots and there was nothing. So what did I do? I asked and that's my second point for today actually, is the chatbot arena, benchmarking LLMs. I did open ChatGPT, but I always have this second one, which I want to talk about a little bit, maybe after your news. Yep. And at the beginning, there were 2, there's always 2 comparisons. I don't know which LLM is behind it. The first 2, and I forgot to write them down, is they had no clue because they had no connection to the internet. So they were both saying, the AI has not yet been finalized.
Oh, okay.
And then you can just restart. You say they're both bad because, they both don't give me a solution. And then I tried again. And then interestingly, Claude 3 Haiku
Yes.
says the AI Act you reference to has not been finalized. So that's another one. That's not good. But the same company, Claude 3 Sonnet. Okay. And that's going to give 2-3 quotes of this one. It says, as regards AI systems that are safety components of products or which themselves, etc., etc., etc. I'm not going to continue here, but it's explicitly referring to machinery, pressure, equipment, etc., etc. And I'm just going to stop there because what I really suggest, and I'm rather certain that you have an idea, I believe what we have to do is at some point in time, next couple of weeks, next couple of months, we need to invite a specialist, which is going to, help our listeners to really...
First, we have to invite a specialist for our podcast, but I come back to the Alps because I'm fully focused on the Alps in this week. At our event, AI in the Alps, we have the specialists in a workshop. So Thomas from Trustify will tell us what the industrial sector needs to do now and what is critical and what is not critical.
Was Thomas with you half a year ago or a couple of months ago, right?
Yep.
I think at that time we had a rather, or was it more like of an interpretation from their side as well? I think, and that was good. I think what it is we need to do now. I strongly believe we should now stop talking about is this good or is this bad. We can still do that. I'm not going to forbid that, but I believe what the point is for all of our listeners now. Finally, now they need to make sure that at least I believe within 2 years, but we're going to hear that confirmed. They're going to make sure that whatever is going to be their embedded industrial AI, they're going to be able to put it onto the European market, right? So, I mean, politics aside, you can still do that wherever you want to do that. But the other thing is making business. And making business means you need to apply to conform to European law.
I think it will be exciting to see now how the standardization work progresses. That's, I think, the most important point, because now you have the AI Act and now the standardization work is going on. That's very important, I think, what's happening now after the AI Act.
I've been looking also this morning and the last couple of months. I know from the past 2-3 years ago, we've had interviews with ZVEI, a German electronics industry, VDMA, German Machine Builders Association. They all had their specific, not always that positive. But I've been looking for the last couple of weeks and there was never a specific answer on now it's there, now we're going to do ABC. But then again, maybe I didn't look in the right places.
Yeah, me too. I saw nothing, yeah.
Okay, so maybe you go with your piece now and then I'll join again, saying a little bit about the LMSys chatbot arena.
Yeah, I have also a regulation topic because the German magazine Capital, it's called Capital, reports the Federal Ministry of Economics and Climate wants to regulate the emerging market for robots based on AI and define basic safety standards. They want to establish a testing center spread across several locations. And I must say, I'm skeptical. We have good regulation when it comes to robotics. And my opinion is, please do not add more regulations on the robotics because, as I said, we have good robotics regulations. And I think we do not need more regulation on this.
Sure. And then you bring us immediately again into what is this and what is the AI Act and does the AI Act not implicitly also regulate wherever you're going to put the AI? It doesn't matter what.
Yeah.
And that's again of course a discussion on was that good? Is that good? Horizontal, vertical? I don't know how many other different ways you could. But it's again very interesting. I didn't know that. Very interesting to hear that in addition to having now a European-wide AI Act, again, countries, in this case, Germany is going to have their own additional regulation as far as AI in robotics is concerned.
Yeah, I think that's another good idea because I think the whole topic robotics is also part of the AI Act because it has to do with safety and safety is a crucial part in the AI Act. Yeah, I'm not convinced.
Okay, so then maybe we're going to hear about, and we can include then this topic as soon as, one of us is going to be talking through the specialist.
Yeah, absolutely. We can talk to maybe the guys from Applied AI, or we ask Thomas once again to explain us.
Yeah, there's many. Let's see who's interested in sharing their latest, greatest thoughts on applying the AI Act.
But you want to talk about Claude, I think.
No, not Claude specifically. But it's fine. I just refer to this, what is called LMSys chatbot arena.
Okay.
So every day, if you're following, and of course we must say that, and you and I, we don't want to just explicitly concentrate on LLMs, but LLMs have been so important. Whatever interview we do these days, and like the last one, I do always explicitly ask, like Peter from Silo just 2-3 days ago, I ask, you guys have been doing, now they have been doing LLMs since the beginning. That's very untypical, right? But then the most of their, over 200 use cases, most of them are machine learning. So I always specifically ask, what about machine learning? Are LLMs going to take over? So you and I, we do not want to concentrate, but LLMs have become very important. So there you go. Every day we see tens, if not hundreds of claims of all the LLM builders on the basis of one or the other benchmark. And then it's up to the community, typically the technical people, those that are a lot more technical than I am. But that's not the point, right? In the end, it's like for all of you listeners, and all of you listeners, some of you are very technical, some of you are decision makers at a high level, more strategic, and all of us need to be able to understand. So from that perspective, I like a lot the approach that is taken by LMSys. That's how they're called. It's not.
How is it called?
Yeah, LMSYS. And we need to be careful if you look for them, because I did already a couple of times on LinkedIn, and now there was a French company lady who said it's not them. So it's LMSys in combination with UC Berkeley Skylab. That's and there's a couple of names here, and we're going to put them in the podcast notes. So they ask users, whoever is interested in using large language models, in a pairwise comparison. So like this morning, I opened ChatGPT and I said, oh, no, I don't want to do that. Yes, I do want to do that, but I rather go to this LMSys chatbot arena. And then there is, you put in your question. In this case, I said, what does the AI Act on, and then I give a URL, say about, machinery, question mark,
Okay.
And then you see left and right, you see two chatbots, they answer you.
So it's a battle.
Yeah, and you compare left and right. And then you say, oh, well, that's not very clear. They're both kind of okay. They're both very good. They're both very bad, whatever. And then you, after one or two times, you're going to vote. The left one is good. The left one is, and then when you vote, then you see what you voted for, right? Now, and what they have done in the meantime, they have evaluated 73 models of, I think there's like 500,000 models, so they can't do all of them. And they have received over 400,000 votes. Now,
whoa.
I really hope that it's soon going to be 4 million, 40 million, 4 billion votes, because if that's what they're going to be able to do, and they need support for that, and that's why I'm sharing it here, they can then break it down by use case, right? Then they're going to say, what do you need to, what was this person doing? This person was asking for a translation. This person was asking for information on the AI Act. That person was asking on whatever method. So then you can do like whatever they are going to choose. They are professionals in this area. So I'm very, very much looking forward to, please join me in, doing your LLM requests at chat.lmsys.org.
Oh, that's very interesting, Peter. How do you come along with that?
It was Peter. Peter, if you're listening, I think your family name is Gostev. I'm not 100% sure. And Peter, at some point in time, I see his feedback on large language models almost like on a daily basis. And he, maybe 3 months ago, he referred me to it. Having said that, Andrew Wang,
Yeah, Bosch Rexroth, yeah, Landing AI. Yeah, we already talked about that.
He had it in his blog last week. He had it in his blog last week as well. Not specifically, but he was referring to I forgot. And then he said, as represented on the chatbot arena. The chatbot arena is one. So it is being referenced to one or the other company, but mostly, I must say, any of the LLM builders, they pick out one specific benchmark. And I'm not saying that those specific benchmarks, whatever they are, on human intelligence, on translation, there's hundreds of benchmarks, but specifically they pick out one. And then, okay, well, you are better than the other ones, but what does it mean? And I love the idea, final quote or final saying, these are chess-style ELO ratings. So as you know, I started looking into chess, but that's not the point. It's not for chess people, but it's ELO. ELO is the guy who in 1960 organized the statistics-based systems of ELO ratings. So today we have Magnus Carlsen. He has an ELO of, let's say, 3,276, and he is the best player in the world. And I've got an ELO of, I have no idea, maybe 800, so there's a
800, Peter, really?
lot of room for improvement there. But that's not so the point now is that GPT-4 family has been on the top for a long time. And the top 7 has been proprietary as well. So the open source community is looking at, and maybe that's going to happen soon, one of the open source solutions moving into the top 7 space. So
I come back to heavy metal because I have another recommendation for our German-speaking listeners. I recorded an episode for the colleagues of Bosch about welding and AI and how they fit together. I will put the link in the show notes. It has nothing to do with LLMs. It's traditional machine learning. So we still have a traditional machine learning in the industrial sector.
Very good. Is it going to improve productivity? May I assume? Is it going to be like more towards automation? Is the vision going to recognize whatever the quality of the piece that needs to be melted? Or
yeah, exactly. And it's about documentation and about quality.
Okay, very good. I'm preparing for a presentation in Houston. I'm going to be doing. I maybe talk about it in 2 weeks from now.
Yeah, they're using OPC UA.
There you go. Because the big topic I have in my brain, and I'm going to talk a little bit about OPC UA, but I haven't decided yet. But the big topic is always about how well prepared needs to be your data for improving the final result. And as you know, and some of our listeners know, you and I, we do the OPC Foundation podcast as well, and OPC UA and information modeling. And now I'm looking into the relationship between the organization of, graphical charts and OPC UA. And I did find very interesting research. I couldn't download it yesterday on Sunday. And I may be, sharing whatever I'm finding in our next news.
You should also listen to the podcast by Bosch, Welding and AI.
Okay, I'll certainly do that.
So, Peter, do you have anything else?
No, nothing more for me.
Yeah, let's get to the main part. Schaeffler and Siemens introduced their Industrial Copilot. So enjoy listening. Thank you very much, Peter. As I told you, I will be strapping my skis to the car, and I hope you have a nice Easter holidays.
Oh, are there Easter holidays? I didn't know.
Yeah, there are Easter holidays, and hear you in 2 weeks, Peter.
Very good. As you know, if you don't have children that go to school, you're not that much aware of when the holidays.
Exactly.
Have a wonderful skiing time. Looking forward to hear from you in 2 weeks again, Robert.
Thank you. Bye-bye.
Thanks. Bye-bye.
My guests are Erik Scepanski from Siemens. Hello, Erik.
Hello. Thanks for having me.
And Julius Bockamp from Schaeffler. Hello, Julius. Welcome.
Hello. Thank you for the invitation.
Before we start, please briefly introduce yourself to the listeners. Erik, please start.
Hey, I'm Erik. I'm an innovation manager for Siemens. I work for Siemens for almost 10 years now. My focus is on AI in factory automation.
Okay. And Julius?
I am Julius Bockamp. I am also innovation manager specifically for production technologies. And our goal of the department is to bring new and innovative technologies to our shop floor, to develop them, to integrate them, or to support the integration, and to make our production faster, better, and more sustainable.
Okay. So, Erik, before we start, briefly, what is the Industrial Copilot by Siemens?
The Industrial Copilot is our answer how to integrate large language models into engineering as well as operations of machines. Yeah, the Industrial Copilot for engineering is trying to optimize workflows in the engineering sphere, and the Industrial Copilot for operation is addressing operators as well as maintenance personnel.
Okay, so it's based on a LLM. It's based on a OpenAI LLM or a Llama, or what is it?
Yeah, it's based on our collaboration with Microsoft. So it's Azure OpenAI services.
So, and do you sell now this Industrial Copilot to your customers? What do you sell there? Is it a software stack? Is it a service product, or what is it?
So we need to separate those both areas. One, the engineering Copilot is basically software that you install right next to TIA Portal. It communicates with TIA Portal via openness and makes large language model capabilities accessible for your engineering tasks.
And the second, so it's software stack and service?
Yes. And the second, you have a new front end to communicate with your machine. Basically, you can ask the questions that come up to your mind related to the machine. So why is the machine not running? How many parts have I produced, or has this machine produced during the last hour? It's a new way to communicate with the machine.
Sure, but I want to go back. You mentioned, okay, it's a software stack in the TIA portal, but is it also a service product by Siemens, or what is it?
So we do not have a product yet. We're currently working on the software for both. It's a software, but it's different for both areas, right?
So it's not a product yet, but Schaeffler is a first partner in testing this, Julius?
We are the first partner in testing. So regarding the PLC engineering use case, we will shortly receive the first licenses to test in our special machinery. The special machinery is our partner internally at Schaeffler in development and integration of the software. Regarding the operations use case, when we talk about the machine operation and cycle times, whatever, there we will also shortly start a project to evaluate possibilities, but also of the boundaries of the technology and what's needed, what are the requirements to bring to the shop floor. It's regarding the PLC programming, it's not only a customer relation. So we created data for Siemens to train the Copilot for prompt engineering, and also provided the basis. But it's also what we are proud of, that it's not only a collaboration, but also a co-creation.
Okay, perfect. How did the collaboration or co-creation between Schaeffler and Siemens come about, Julius?
Yeah, we started with a collaboration after the last HANNOVER MESSE. We invited Siemens to our Production Technology and Innovation Center. That's where our innovation place is. We have several rooms. We have 800 square meters of testing area. And there we evaluated what we could do. And we directly saw the extremely high potential of the Copilot. But we also saw, of course, that it is in a very early development state. And we wanted to boost this development. So we decided that we delivered Siemens data to be able to shape the Copilot and to make it reality way faster.
What did you shape, Erik, with the data from Schaeffler?
So we started our journey in September 2022 to evaluate different language models, for example, GPT-3, and had some discussions with different customers regarding the potential of these large language models. And then all of a sudden, OpenAI released GPT 3.5 and ChatGPT. And then we started to work on first use cases to really drive this topic for factory automation. And when we met Schaeffler, we already had some use cases in mind, but we weren't sure what we really should focus on. And the discussions with Julius and his colleagues were really helpful to guide us to use cases that have a huge potential for many of our customers, not only for Schaeffler. And they were really, really great in explaining how they work, where they see potential for improvement. And this helped us a lot to, as Julius said, make the Industrial Copilot a reality.
And what did you do with the data from Julius? Why do you need this data?
We needed some description of how they program their machines and first understand how they to program the sequences they have. And we took those descriptions to generate code out of it. This was really helpful to understand the mapping between what is an input for automation engineer and what is the expected output. And then we iterated on the prompt engineering and came up with solutions that fit the expected output, right?
So the data by Julius' team is generalized and then it's added to the prompts by Julius' team when they work together with a Copilot, or what is the idea?
No, it's not added to the prompt directly. It's added to the user prompt. Yes, that's the case. But we always have the system prompt and the user prompt, and we combine them together. So we took the user prompt by Julius, and I had a look at the expected outcome. So how should the sequence look like? And then we iterated on the system prompt to come up with a good solution.
How do you manage this combination of a user prompt and the system prompt, or the data of the system? So the user is typing the prompt. What happens then in the backend?
In the backend, we combine the user prompt with the system prompt.
But how do you combine it?
We just combine it. This is how you normally do it with large language models. You always have a system and a user prompt. You don't combine it. Yeah, these are different inputs for the LLMs.
Okay. He's typing his prompt and then the prompt gets more information by the system, right?
Yeah. For example, you can think of ST code, or in our case, SCL code. The user writes, okay, give me a block to control a conveyor system with 2 motors and 4 sensors. And this is the user prompt. And yet then you add a system prompt, which represents the logic of SCL or ST code, and then we guide the model to a better result.
Okay.
And that's the same for different use cases. So I talked about the sequences. So we showed that we're able to generate S7 graph code, and we do the same there. So we took the user prompt of Julius and added some system prompt to it so that the model is capable of generating S7 graph code. So normally it's not able to do so, but we added the system prompt there.
Okay. Julius, Erik mentions some use cases. Which use cases do you identify with your team?
Regarding the PLC programming, I would say the most important use case are the PLC programmers itself, because in this area, especially in our own special machinery also, but of course worldwide, we have a shortage of programmers, of skilled labor. And this is one measure to make our workforce more efficient.
How do you measure that efficiency on programming?
I would say it's too early to measure. By now in a pre-development phase, and we want to evaluate the capabilities of the technology, but also the requirements. I think after the test phase, so the test phase will start in 2 weeks, maybe roundabout. And after the test phase, we will, I think, be possible to talk about efficiency gains. Now we just have an idea what could be possible. And the test product from Siemens we will receive will not be capable of the full range of what is generally possible. So also there, the capabilities will become bigger and bigger time after time. But really, it's too early to give such ideas on how much efficiency gain is possible.
Okay. But I think you have something in your mind what could be possible.
Like I said, I think it's too early. We should really focus on the test phase, and then we can come up with real values.
When you now implement the Industrial Copilot, how do you do that at Schaeffler? What needs to be done before you can start, Julius?
So we have the 2 versions, right? The PLC programming, they are already on. This is quite easy to implement because it's based on TIA portal, Total Integrated Automation. So it's just an add-on. That's quite easy to roll out. Regarding the operations use case for the machine operator, it's way harder. We have to evaluate what kind of data we will need. We have to evaluate how to connect the data to the Copilot, and we have to evaluate issues like IT, OT security. So by now we focus on the capabilities, and then from this on to evaluate what is needed. The Schaeffler Special Machinery, our partner in the project, provided a machine that's originally a fair machine, but it is a real machine with real code, real parts, real part handling. The only difference is that the parts are put around in a circle infinitely. And this machine now is used to evaluate what's needed on our test area. And coming from this, then we will evaluate on how to proceed.
So it's evaluated what is possible on the engineering side and the workforce side of both worlds?
We are having a look on both, right? Yeah, of course.
Let's stay at the engineering side. What has to be done now with your guys who are programming the PLC? What they need to know, what will change in their daily working life?
They will be released from repetitive work. So the Copilot is capable of providing suggestions, of providing help. The Copilot is by now at least not really capable of providing complex architectures and really creative work. So the programmer will be able to focus on his key competences. Also, that's what's the fun part of programming, right? Let's take a 7 graph. If you have to change a number and you have to go into 50 blocks and change something, that's not fun, right? And this can all be automated with the Copilot. And what the programmers need to learn, of course, is how to handle the Copilot, because it's a new tool and prompting need to be learned. It's not that complicated, but you should generally know on how to use it, how to prompt, how to change prompt, what's important, how can generative AI understand what I want to have done. This need to be somehow trained.
How you train your guys?
The training now will be done jointly by the development team we have between Siemens and Schaeffler and Siemens itself. Because we are now in a test phase, there we have the development team, and at least for the test phase, the development team will train our programmers to use the software.
Erik, what they need to learn? Julius mentioned prompt engineering, but how do you train them?
As Julius said, our Industrial Copilot has limited functionality at this point in time. So we will walk them through the different use cases. We tell them what is it capable of at this point in time? How do you do it? And we also work on adjusting the processes at Schaeffler Special Machinery. For example, I told you about the process description of the machine. So we jointly worked on describing the processes in a way that the large language model is capable of understanding. So we provided a template, and this will be something they can use. So they just take the template and adjust it to their needs. And that's why we think it will be easy to use the Copilot, because we get some predefined templates to do the prompting.
So in my opinion, every week you get new prompting guides, guidelines and stuff like that. But the future should be that we talk with our language to a machine or to a model. Is that a way to go?
Yeah, definitely. It's a way to go. It got better over the years. So now you can just speak to the model and add some specific prompts, some guidelines that you were talking about. But in the near future, we might be able to describe it in a informal way, I don't know, if we talk to each other, and we do not need to add some specifics like I'm an automation engineer, I provide high quality code in the prompt. So this is something we will fix in the future, but now you need to add some stuff and you need to describe it a bit more than you would normally do it when you talk to a colleague.
Julius, I want to come back to the rules. What are the rules of the game when using the Copilot in a Schaeffler environment?
As long as we are not sure that the data is handled securely, we cannot upload confidential data, of course. So everything we do by now is mostly limited to data that is possibly to share, right? Where they have the possibility. Regarding Siemens, we have a non-disclosure agreement, so we can be more open. But we, of course, also have our own chatbot at Schaeffler, and there we have different stages on which data can be added or which should not be added. So strictly confidential data, for example, can never be added just because we are not completely sure on how the data is handled in there. For internal data and things like this, we can just use it.
I have one more question concerning the infrastructure, Julius. You mentioned, first step, engineering. I think this is operating with a cloud connection, right?
Yes.
Yeah. And you also talked about the workforce on the shop floor. And in the future, they should also use LLM or Industrial Copilot. But this should also run in a cloud or on an edge device, Julius? What is the idea?
I really have to say again, it's a little bit too early to say this. This really depends on how much computing power is needed. But to know how much power is needed, we need to evaluate what we want to connect. And here we again have an issue because the more data we add, the more useful the chatbot or the copilot will be. But the higher the complexity is. And this complexity, again, must be handled. Then we also have the need to know principle. So, of course, not everyone should be allowed to access every information thing. And therefore, we just have to find a way. But this is part of the project with Siemens where we are working on together. Also on where to host the data, where the model will run. So will it be a Schaeffler cloud? Will it be a Siemens cloud? Because we, of course, data security rules. And we must be sure that our data is handled in the way we have the requirements for.
When we talk about data in a company, we also talk about different hierarchies of data, who is allowed to enter data. Do you have a solution for that, Erik?
So we're thinking of different solutions. One part is entering data and one part is accessing data. So we need to have a hierarchy, as you said. We're currently working on that and it's not finished, but our customers always tell us that there needs to be some kind of data access management as well as entering.
Julius, what about Schaeffler, hierarchy of data?
Yeah, we will also have to find solution for this. Reason is that especially when we talk about the shop floor solution, which should help machine operators, they have a high value in this application. They need to be able to add data. But here we must be sure that the added data is, of course, correct. And the question is who enters data where? And we are in an early stage and we will take a look on how this could look like, how such a hierarchy could be shaped. But for now, we are in a pre-development where we just, like I said, focus on requirements and capabilities. And this still is unfortunately a little too early to answer.
Erik, one topic I need to add, because when we talk about LLMs, we need to talk about hallucinations. How do you avoid hallucination in this use case?
We always try to give the source. This is one part. So you're able to access the data that it's referring to. And we are using function calls and our openness API. So we make sure that the model is just doing the stuff that it's asked for. So the model won't start creating SCL code when you ask for a S7 graph, because it is grounded on the API that we have in TIA portal.
And Julius, I want to come back to the shop floor, and you mentioned your workforce there. What can you imagine on the shop floor? Can you describe maybe 2 or 3 use cases?
On the shop floor, time is money. So whenever we have a downtime, we need a very fast solution. And by now, when we have a downtime, the machine operator will go to his team leader and they will try to find a solution together by looking into handbooks, by looking into previous solutions that they had. They will most likely also ask the maintenance. Maintenance will make a ticket and also log things there. But this all is a time-consuming process. And with the shop floor copilot for the machine operator, we expect our workforce to be way faster here. When we have downtime, we always have a reason. There's most likely a reason code. Maybe a sensor was broken, maybe there was too high vibration. And when we directly know what is the reason and we don't have to look in the handbook, we most likely way faster have an idea on how to fix the problem. Sometimes the downtime can have a much more or easy reason. Maybe there's just material missing or things like this. And this information we can retrieve very, very fast with an LLM.
What Julius mentioned is very interesting, because he said the workforce will get information about the problem via LLM. But how certain is this LLM? Do you need an explanation to the workforce, how certain the model is that this is the right solution?
I don't think that we need a number there. I think we can address it by adding some sources, as I said. So if you have a document where the error code and the step-by-step guide how to fix the issue is written down, this will be very helpful for the operators. But I don't think that we need to add like I'm 80% certain to it, because what does 80% mean, right?
We also have recommendations mostly, so the machine operator will still make sure that this is the right solution. This is not directly something that's added to the machine. So we still have some some control of this. So we would not at that stage let an LLM control our machines.
Yeah, and that's why we name it Copilot and not Autopilot. It will always have the human in the loop and give some guidance, some recommendations, as Julius said.
Julius, what is the time horizon now? What are your next steps?
The next step is to bring, regarding special machinery use case, the test pilot into production, the test co-pilot, so that we can give feedback also to Siemens, what's working well, what's working not so well, and where we need adjustments regarding but this will be quite fast. Regarding the operations use case, we have way more uncertainties. What's really needed. So the next steps here will be more to build the foundation on how to build such a co-pilot, what to add regarding data, what to add regarding analyzing capabilities, that we just become sure on which direction we want to go. This will be the next step from my perspective.
My last question is, what are your tasks in the next few months, Erik? Learn from Schaeffler, learn from the data, learn from the feedback, adjust the co-pilot. What is your job?
That's exactly what we're going to do. We want to learn from Schaeffler. We want to adjust the use cases that we already implemented, find more use cases, measure the impact of our solution. And that's what we're trying to do in the next couple of weeks and months.
Okay, Erik, all the best. Thank you very much.
Thanks a lot.
Julius, all the best with the Industrial Copilot, and we are looking forward to your measuring results, what comes out. Thank you very much.
We're also very curious regarding this. Thank you for the invitation.
Bye-bye.